Our today's topic is vectors, and this is a very vast topic, and students have a confusion about it. So first, I would like to tell you a few things about the vectors. The vector represented by a line in any direction. It's an arrowhead, either in the at the end or in between, and the vector is written in the form of A over B. That is called the column vector. In books, you will find they generally write a vector with a bold one. In examination paper also, a bold one. This is a vector. When we write vector, sometimes we write it like this way. That is the symbol of the vector. Vector can be written as this way. So these are the three ways how we write a vector. That is the first thing. Second thing is they are always represented by an arrow in any direction, and this arrow is correlated with the column vector. Let me explain to you how it is. Suppose we have a column vector, say 2 and 3. So 2 is supposed to move in this direction, and 3 is supposed to move in this direction. So this can be started from any point. Say this is 1 and 2 and 3. 1, 2 and 3. So actually this is the vector. So if this is a 2 3, that is how it's represented. So this vector is 2 and 3. Now suppose if I have to add say 1 and 1 in it. Suppose this is 2 and 3. This is say A, and vector B is say 1 and 1. So we'll start from here. This one is going in this direction, and this one is going in this direction. That is the end point. So this is the vector now. So if you add it, you can see 2 plus 1 is 3, 3 plus 1 is 4. So this is 1, 2, 3, and then 1, 2, 3, and then 1, 2, 3, and 4. So this is our resultant vector. So either it is written in this form or in this form. The meaning is same. That is the first thing. Now, second thing is, first is about the representation of the vectors, whether it is in the form of an arrow, it is form of the column vector. Second thing is magnitude. Magnitude is a kind of a fancy word. It means the length of the vector. That's all. So if somebody wants to know what is the magnitude of a vector, you just say the length of the vector. But there is a formula. For example, this is 3 and this is 4. So you have to calculate this length. You know, it always make a right angle triangle. So you do what? You do what? 3 square plus 4 square, that is 6. This is 16 plus 9. 3 square is 9, that is 25. And then you root of everything. That is how we use Pythagoras theorem. So it's exactly a Pythagoras theorem. So this is going to be root 25, that is 5. So the formula for magnitude or the length is whatever is written on the top plus whatever is written on the bottom. You square it. It's a Pythagoras theorem and nothing else. So whenever somebody asks the magnitude, it means they are asking you the length. So if this is a vector, so the length is this and this. That is how we write it. Another thing I want to clear here is, suppose it is minus 2 and 3. Suppose the vector is minus 2 and 3. So you can start from any point. I told you A will go plus, so minus A will go down. No, minus A will go in this direction, x opposite. This is x1, and minus B will go down 1. So this is minus 2. So let us start from here. Minus 2 is 1 and 2. This is minus 2. Then from here 3. 1, 2, 3. So this is the resultant vector. For example, how will you name this vector? It is there. So let's take 1, 1, 1, 2, 3, 4, 5, 6. And this is 1, 2, 3, 4, say 5. This is 5. Now this one is going from the starting point. This vector is going there. Starting point is going in this direction. So this is minus 6. And this is going up 5. So this is the column vector. I have told you how to add the column vector. So this is about a column vector, the magnitude. Now from the examination point of view, what you have to know is that they ask basically 4 things. Number 1, what they ask is find magnitude. Which I have already told you. So it is just a length, and that is root a square plus b square. It's as simple as that for a vector AB. If it is negative, you write it negative. If it is positive, you write it positive. Point number 2 is add or subtract vector. Now add or subtract means, in the column I have told you, if it is 2, 1 plus minus 1, 2, you just add this one. 2 and minus 1 is 1, 2 and 1 is 3. But if comes like this way, this is A and this is B. So you have to, this is A, then B will start from here, the same direction will not change. So this line from here to here will be A plus B. So we'll see the questions like this. There are so many questions where we are having. For example, this is C, and from here say it is D. So this resultant vector is C minus D. So suppose this is AB. So AB, A to B, sorry, A to, say this is E. A to E, then E to this. So this is a negative. I'll explain to you later. That's how we write plus and minus. These are the 2 things about the exam. The third thing is question number 3. And in our this lesson, more emphasis will be on this point, and that point is using vectors in most of the exam. This question comes, using vectors show that certain point lie on in such questions. What you are going to get it, there will be this kind of a figure, then this one is there, this is crossing at P. So show that P lie on line AB. You have to show this one. The the parallel vectors are, suppose this is a vector A, this vector can be point 2A, this vector may be 3A, this vector may be 1 over 2 or 7 over 2A, something like this. So what common is here is A. So these are all parallel. If you prove these are parallel or something like this, it shows that it is lie on it. For example, in this question, if you show that AB is equal to, suppose, A plus 2B, and you show that AP is equal to, say, 3A plus 2B, and you show that PB is equal to 4 over 3A plus 2B. So here you have seen that this thing is common. That is the way to show that they lie on the line. That is the way. Now the fourth one is, that fourth one is very important, and that is the fourth one, that is involving ratios. The questions involving ratios. That is called a ratio theorem. Let me explain to you. Suppose this is a line, say AB, and this is a vector AB. Suppose there is a point here, C, and this point is dividing it into the ratio of 2 is to, say, 5. Now you know it very well. What is this length? And say this is AB. What this length is? This total length is divided into 2 plus 5, 7. So this portion is 2 over 7 AB, and this remaining is 5 over 7 AB. That is a ratio theorem. That's all in the ratio theorem. Most questions are like this. So now you know the length of this vector, you know the length of this vector. So it is very easy for you. Suppose this is the one. Now this is A. So if you have to write vector OC vector will start from here. That is A plus. Now this vector, this is 2 over 7 AB. Then you have to calculate AB in terms. So that's how we do the questions. So these are the main things which you are supposed to know before you start the vectors. Now let's take a question which is going to clear our concept about the vectors. Generally the question comes like this and you have to write it. Now OXY is a triangle. OXY. OX is 2C. This is in this direction. You always remember the direction. OY is 3D. This is going in this direction. Now he's not talking about XY here. He's saying find XY in terms of CD. So XY. It means you are standing at X and you have to reach Y. This path you don't know. So you will move this way. So you are moving in opposite direction here. 2C is in this direction. Now the magnitude is 2C, but the direction is opposite. So you are going to write it minus 2C, and you are moving in this direction. So it means you have started from here, you traveled up to here, then from there you started traveling. So this 3D is in the same direction. So that is plus 3D. And that is the answer. That's how easy the vectors are. So this is XY in terms of C and D. So this is your answer. XY in terms of C and D. Now second question, let's see what it is saying. is a point such that now it is divided into 2:3. So it is saying XA is to AY is equal to 2:3. Show OA is parallel to CD. OA parallel CD. Parallel CD or lie on the same, it is the same concept. Now let's see what he's saying and what we are supposed to do. Now see here, XA. So this is 2 and this is 3. So as I told you, this is 2/5 of XY, or this is 3/5 of XY. This is the ratio theorem. So I hope it's clear to you. Now for this, to find this vector, which vector we are supposed to find, where it disappear, what we have to, OA parallel CD, that is what we have to find. OA. It can't be parallel CD. OA is the parallel to the vector of CD, not CD, because CD O is parallel to vector CD. Means whatever we are going to find OA, that is going to become, it may be 2C plus 2D, or half C plus half D, something like this. So in the bracket C plus D will be there. Let's try to solve this one. So first we have to draw OA. Now you are at O, you have to reach at A. So first you travel to C. So OA is equal to, we are going in the same direction, plus 2/5, this one, but we don't know this because there is nothing. This is XY, not in terms of C and D. So first we have to calculate XY also. So let us write down. This is XY. We have already calculated. XY is minus 2C plus 3D. But it is 2/5 of this. So minus 2C plus 3D. This is the part you have to understand. We have calculated XY. Here we are using the ratio theorem. If this value is supposed to give it 3/5 of this, so now OA is equal to 2C. This is 2/5. So 2 times 2 is minus 4/5C plus 3 times 2 is 6/5D. Now these are the like terms. So I can solve it. 5 times 2 is 10 minus 4C over 5 plus 6/5D. 10 minus 4 is 6C over 5 plus 6D over 5. I can take 6/5 common. That is what it was asking. That is what I told you, that what our answer is supposed to be this same, so that we get C plus D. So this means this is the what we is asking is that it is C plus D. C plus D is they have not given any vector. They just wanted to know whether it is parallel to C plus D vector. So if this is vector C and this is D and this is the C plus D, so this line is parallel to this another vector. That is the question. That's how they ask the question. This video is getting very lengthy. Uh, I don't want to make one video which is more than 20 minutes. So I'm just going to take question number 1, which I gave you, and then I'll post the remaining question. I hope this video is going to help you to do those questions. So let me go to the question which I gave you. I don't have a question ready, so I've made this diagram. That is, it is saying that OBDE, OBDE, and OAFG, OAFG. So what they are saying is this is a parallelogram, and also this is a parallelogram. Now this is a A. It means this is A. This is A. Is A the midpoint? Yes, A is the midpoint. If it is a midpoint, so this is also A. And they are saying B is the midpoint. B is the midpoint. So this is B. This is B. This is B. You can see it yourself because this is the same direction. So that is the first thing you're supposed to do in a question. I've just tried to give some hint in the question paper also, so that those who want can get it. Now first part is OC. I think this is not difficult. See, this is B, this is B, this is B, and this is the midpoint. This is B, this is B. It's visible also, so you can, and these are the A. Now you have to find OC. OC, where is C? It must be C. Now you start from O and you reach C. So first you move here, that is A, then you reach here. So reach here and then you reach here. So this is OC. Now BA. Generally exam questions are not that complicated, that you have so many lines. So we have to find BA.